Good day, students. The topic we're having in chemistry today is on is salts. The last time we treated acid, bases, and their properties, the chemical properties and physical properties. And today we are looking at salts. And I want you to recall that when acid reacts with base, you get salts and water. A neutralization reaction. This is neutralization reaction. Now, so it means a salt is formed when acid and bases react together. We have other ways in which salts can be formed. So salt is more than the table salt you use at home, the sodium chloride you use at home. We have other types of salts. Some of them are soluble, some are insoluble. Now, we have different sources of salt as well. We can get salt from the sea. We can get different salt from the sea. We can get sodium chloride. From the sea, we can get sodium iodide, sodium bromide, and so on and so forth. Now, we are looking at the types of salts. But before that, I'll give you a better definition of what a salt is. A salt is actually a compound formed when all of the ionizable hydrogen of an acid is replaced by metallic or ammonium ions. Now, please recall that in acid we treated basicity of acid. Let's take this for instance. Tetraoxosulfate 6 acid reacting with sodium hydroxide. Now, when these two react together, we have this splitting into their ions. Hydrogen has +1, tetraoxosulfate 6 ion has -2, sodium has +1, and hydroxy ion has -1. Now, when you combine these two together, you see that the positive will combine with the negative. When these combine, so you have Na plus SO4 2 minus, there will be an exchange of radicals to give you Na2SO4. And then when this hydrogen ion and hydroxy combines together, you get water. So this is formed Na2SO4 and water. This is sodium tetraoxosulfate 6 from tetraoxosulfate 6 acid. Now, and we also have water, salt and water. This is the base. We describe base as metallic oxide or hydroxide, and this is the acid. Now, this is an alkali, which is a base. Now, if you take a close look, you will notice that we have two atoms of hydrogen here, and the two hydrogen has been replaced completely with a metal. So, if you can still remember the definition of basicity of acid too, that the basicity of an acid is the number of replaceable hydrogen ion in 1 mole of that acid. Number of replaceable hydrogen in 1 mole of that acid. Now, 1 mole of tetraoxosulfate 6 acid is what we have, contains 2 hydrogen. So the basicity of H2SO4 tetraoxosulfate 6 is 2. Now, the 2 hydrogen there has been replaced. Basicity of an acid is the number of replaceable hydrogen ion in 1 mole of that acid. Now, the 2 hydrogen here has been replaced completely by a metal positive ion, which is coming from a base. And then this hydrogen is taking the place of a metal here to give you water. And then we have sodium taking the place of hydrogen here. So in that case, it means that a salt is actually containing 2 features. We have the positive and the negative. Now, if you split these salts, now you will get Na plus 1, SO4 2 minus, because sodium actually is 11. When you arrange sodium, the first shell will take 2, the second shell will take 8, the last shell will take 1. And this one is a radical. Just like we have CO3 2 minus, trioxocarbonate, we have NO3 minus. Now, it's your duty to know what these radicals carries, their charges, and so on and so forth. Now, so that when you are writing the equation of reaction, you'll be able to split them. So this is a salt. A salt is made up of a metal and a negative radical. Now, what are the other examples of salts? Let me give you one here. When hydrochloric acid reacts with potassium hydroxide, we'll get a salt. So this acid, this is base. This is a strong base. Chlorine is 17,287. It gains 1 to become -1. Potassium is 19. We have 2,881 on the last shell, which gives it out to become +1. Then this radical, OH minus, has a negative there. So by the time this combine with this, you have plus and this coming together, they cancel out to give you potassium chloride. And then you have water. Between hydrogen and hydroxyl of this, you get water. So this is a salt, and you can, if you look closely at this salt, you can see that potassium is having negative while this is positive. So you can see that one hydrogen from the acid has been replaced by a metal from the base to get a salt. So a salt is made up of a positive and a negative electron, or a positive radical and a negative radical. Now from there we move to types of salts. What are the different types of salts? How are salts formed? And when you see a salt, how do you know that this is a salt and this is a kind of salt? We have 5 categories of salts. We have the normal salt, we have the acid salt, basic salts, we have the double salts, and the complex salts. Now, for the normal salts, when acid and base react together, you get normal salt. But a normal salt is actually formed when all the replaceable hydrogen ion in the acid have been completely replaced by a metal. I'm going to give you an example again, which was one I used. This is an acid, tetraoxovate 6 acid, and this is also a base. In this case, this is not an alkali, just a base. Now, this is an acid and it has two, the basicity is 2, that is, it has 2 replaceable hydrogen ion. Now, when these 2 react together, let's try to break them into their ionic reactions. We have hydrogen ion, SO4 2-, then we have Zn, which carries 2, then O2-, oxygen is 8. When you arrange, you have 2 on the first shell, 6 on the second shell, it gains 2. Now, when these 2 combine, you can see that this cancelled out. That was why we got this. Now, and this exchange of valency. Now, by the time this and this combine together, you get Zn2+ and SO4 2- coming together. They cancel out to give you zinc tetraoxosulfate 6 plus. Now we have the hydrogen and the O2 hydrogen, then O2- to give you H2O. This is salt and this is water. Permit me to clean this. Now, with what we have here, you can see that here we have 2 hydrogen and here we have 1 hydrogen being formed. Balancing the equation of reaction, you see that hydrogen is already balanced here. Now we have only one. There's nothing like Zn2SO4. This is what we get by normal reaction. Even though you have 2 here and here, is zinc is replacing it directly. Another example is that when you have a reaction between hydrochloric acid and sodium hydroxide, these 2 also react together. You have 1 replaceable hydrogen ion here. By the time this reacts together, you have this forming this. You have your sodium chloride and then you have your water. You can see that the replaceable hydrogen ion has been replaced completely. Now, how do we get acid salts then before we move to basic salt? For acid salts, Acid salts are formed when all the replaceable hydrogen ion in the acid is partially replaced by a metallic ion. For normal salt is formed when all the replaceable hydrogen ion in the acid has been completely replaced by a metallic ion. But acid salt is formed when all the replaceable when the replaceable hydrogen ion in an acid is partially replaced by a metal. So in that case, you will see that not all the hydrogen will be used up. Now let's take for instance, again, we have tetrols of a 6 acid reacting with potassium hydroxide. These two, when they react together, you have potassium here is K plus 1 OH minus for hydroxyl, SO4 2 minus, and then we have H plus. When these two react together, at first, normally we are supposed to exchange their valency, but when you get KHSO4, because we have only one potassium here, potassium has plus 1, hydrogen is 2 here, and the reason why zinc was able to replace 2 hydrogen here is because zinc alone has 2 valencies. It has 2 valencies on it. But here, potassium has 1. Even when you bring these together, we still get K2SO4, rearranging them. But there can be a partial reaction to give you this. When you have this, you have potassium hydroxide formed, and we also have water. Now, this potassium hydrogen tetrosulfate 6 can still react further with potassium hydroxide. It can still react further with a base again. Now, in this case now, we have this taking the place of this. We have K2SO4 and then HOH. So here, this is a normal salt, and here you have what? An acid salt, because of the presence of hydrogen. Out of the 2 hydrogen, only 1 hydrogen has been replaced by a metallic ion. Another example, if you have an acid salt that has maybe it's formed from a weak acid, for instance, maybe you have something like this being formed, and then you have KH2CO3, which is in rare cases. Okay, let's use sodium hydroxide here. You have your water. Now it means this can still react further to give you Na2HCO3 plus H2O. You can see sodium is now 2. 1 hydrogen has been replaced again, and this can still react together again with another base to give you Na3CO. Oh, this is a mistake. H3PO4. We have the same thing here, PO4. We have your PO4, which is a weak acid. Now lastly, you may end up having something like this. You will see that all the replaceable hydrogen ion has been replaced, but there was a partial replacement because of the presence of hydrogen here, traces of hydrogen. This is an acid salt, this is an acid salt, and this is a normal salt. So in the next video we are going to treat other types of acid.